One of the most popular ways of solving a quadratic equation is to solve with the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. To help you remember that, if you Google quadratic formula song, you will find all kinds of different options, from nursery rhymes to famous pop and country songs, that you can utilize to help you remember that formula. All right, when you start with the quadratic formula, you need to make sure that it is set equal to 0 and in descending power order. What we mean by that, it goes x to the second, x to the first, and then your constant term. The importance of that is if you have a problem like this one, if you don't do that first, then you're going to misidentify your C value, and it's going to cause your entire problem to be wrong. All right, so if we look at this equation in comparison with the standard form, you can see that A would be 1, B would be 5, and C would be -1. So once I identify A, B, and C, then all I'm doing is just plugging them into the formula. All right, so we said that B was 5. So in the place of each of my B's, I'm going to put 5. Then we said that A was 1. So in the place of each of my A's, we've got 1. And then C was -1. So C is -1. To simplify, you have to be sure that you follow order of operations. One of the most common mistakes is that people want to start at the left and just work straight across to the right. So they say 5 squared is 25, minus 4 is 21, times 1 is 21, times -1 is -21, and that's not correct. Order of operations says that we have to do our exponents first, so 5 squared is 25, and then it says we have to do multiplication and division before we can do this addition and subtraction. So if I do -4 times 1, that's -4, times -1, that's +4. So 25 plus 4 would be 29. That's definitely a big difference from -21. That radical can't be simplified any further, so that is my solution. Here's another one for you to practice on, but let's look at this one since it's more complex. So the first thing we need to do is make sure that we are in general form, which means we're set equal to 0. So I need to subtract this 2 to the other side, and I need to make sure I'm in ax squared plus bx plus c form. All right, so A would be 9, B would be 3, and C would be -2. All right, so let's use our quadratic formula again. Negative B was 3, plus or minus the square root of B was 3, squared, minus 4 times A was 9, times C was -2, all over 2 times A, and A was 9. All right, so again, order of operations here. I'm going to do my exponents first, so 3 squared is 9. And then -4 times 9 is -36, times -2 is +72. So 9 plus 72 is going to give us 81. Now, the square root of 81 can be simplified because it would be 9. So I'm left with -3 plus or minus 9 over 18. And I don't want to leave my answer that way. What that literally means is -3 plus 9 over 18, as you see here, and -3 minus 9 over 18, as you see here. So if we simplify those, -3 and 9 would give us 6, and 6 over 18 would be 1/3. And then -3 and -9 is -12, and -12 over 18 would give us -2/3. So those would be our two solutions using the quadratic formula. Now there's sometimes that I don't need to know the solutions. I just need to know how many there are or what type there are. And in that case, I can use something called the discriminant. The discriminant is just what is under your radical sign. It does not include the radical. It's just the b squared minus 4ac. So let's go back to that first problem that we had, and let's say that instead of solving it, we just needed to know how many solutions we were going to get and what kind of solutions they would be. So I could do the discriminant, b squared minus 4ac. So b is 5, so b squared minus 4 times a is 1, and c is negative 1. So following order of operations, I would get 29 for that. So according to the discriminant, if the answer that I get is greater than 0, which 29 is, I should get 2 real solutions. And sure enough, when we solved that problem, that's exactly what we got. We got 2 real solutions. Now, think with me for just a second. If what was under the radical, if that had been a 0, you would have had negative 5 plus or minus the square root of 0, which is just negative 5 plus 0, or negative 5, right? So you would have had negative 5 over 2. You would have only gotten one answer. And so that's why it says if your discriminant is 0, you'll only get one solution, and it will be real. All right, look at the other one that we did earlier today. All right, for that one again, if I used my discriminant and I did b squared minus 4ac, I would get 81. Again, that's positive, and I should get 2 real solutions, and we did. All right, let's go back and look at this one that we left for you to try. So if we did the discriminant, b squared minus 4ac, a is 1, b is 1, and c is 2, I'm going to end up with negative 7. What does that tell me? Well, that tells me I'm going to get 2 solutions, but they're going to be complex or imaginary. So I would get 2 complex solutions or 2 imaginary solutions for that one when I solve it. Now, one place that I specifically can apply this new information that we just picked up is with the Pythagorean theorem. When we solve a triangle, we know that a right triangle, we know we can use a squared plus b squared is equal to c squared. So in this case, I've got a, I'm going to put 4 in for b, and I'm going to put 12 in for c with the Pythagorean theorem. A and b are interchangeable, but c has to be the hypotenuse. It has to be the side opposite the right angle, the longest side of the triangle. All right, so to get a by itself, we could subtract 16 from both sides, and then we could take the square root of both sides. Don't forget to put in your plus or minus. Let's simplify that radical. So 128 is 64 times 2. So I know the square root of 64 is 8, and I can't do anything with the square root of 2. All right, how did I know to use the positive instead of the negative? Well, it's a length of the side of the triangle, and that length has to be positive.